Welcome back to the C tutorial series. I'm so glad you're here. Today, we will learn about arrays in C, which will also help us further understand how pointers work and how memory is allocated. So let's get started. I created a file called arrays.c, and in this file we're going to create an array. So what exactly is an array? An array is just a collection of data, and it can be of any data type. So in this case, I'll have it be of the float data type, so that's any number including decimal numbers. And I'll say there's 5 elements, and I'll just put 5 random numbers right now, and they can include decimal points since it is of the float data type. If you wanted to change a number, you could do that by just saying number. Then let's say we want to change the number in index 4, so that's what the number inside means. And let's say we wanted to change that to 3. So what would actually change? You may be thinking that the 1 would change to 3, but it's actually the 2 that changes to 3. Why is this? Because indexing in C starts at 0. So index 0 is 992, index 1 is 33, 2 is 33.2, 3 is 1, and 4 is 2. So although it's 5 here, it only goes up to 4 because it starts at 0, not 1. If we wanted to print the values, we could do that by creating a for loop and say for I is equal to 0, while I is less than 5, I plus plus, and say what each element equals by indexing it one at a time. And when we do this, it will work, but this number 5, we could replace this with the size of the number. And you may be thinking, isn't this 5? Well, size of number is actually the length in bytes. A float's 4 bytes, so we need to divide this by the size of float, which is 4, or we can do a little trick here and divide it by number 0, which is a float. Both ways do the exact same thing. And now let's print this and see what we get. We get all of the elements starting with 0 and ending with 4. So all 5 elements are there, and we can see that this works. We can also create an array ahead of time without assigning values by doing int in 10. This is an array of length 10. And then we can create a for loop like before, and inside this we can assign the values equal to 100 plus I. So n of 0 will be 100, n of 1 will be 101, etc. And I'll paste a print statement from above, and now I'll run this. The first element is 100, the last element is 109. So this works. Now that we know the basics of arrays, let's move on to strings. Well, did you know all a string is an array of characters? Now that we know this and know what an array is, we can dive into this. Let's create an array of characters called greeting and set this equal to hello. So you could specify the number of elements you want, or you can leave this empty and then we'll have hello. So you may be wondering, is this 5? No, it's actually 6. The reason this is because at the end of every string you need a null character or some people may refer to as a terminating character, which is \0. It lets you know that you're at the end of a string. I could also create an array of characters like this, and it's equivalently the same thing. And I'm just going to comment this out since we already declared it once. We don't need to declare it again. Well, what if we wanted to create an array of strings? How would we do this? Well, it's actually just a two-dimensional array. So the first grouping of arrays is the number of words, followed by the number of characters in the second. I can insert words to the sentence by doing sentence 0 and say hello, and then sentence 1 world. However, with string copy, it doesn't automatically specify the length. So in order to be safe, we can do string length copy and then pass in the length, which is just the number of characters. I can then print this out using two for loops since it is a two-dimensional array. And I would just need two variables to iterate through. So the first one I can use I, and the second one I'll use J. And I'll just print the character, sentence I, which is the word, then J, which is the specific letter. And let's say I wanted to break this up by putting a new line after every single word. I can do that outside of the first for loop and inside of the second for loop by adding a new line character, and this will work when I run it. So let's see it in action. And we get hello and world just as expected. And it's important to have the string header file located at the top so that we can use string length copy. Another great thing about string arrays is that you can combine them using stringcat, and this concatenates the two strings. And the first parameter is the destination, and the second parameter is what we want to add to it. So in this case, the destination is hello world, and we want to add world to it since hello world just has hello right now. We can print this by saying the result is %s, and %s is a string in C. And if we wanted to see the length of this string, we could do that too. And I'll just say the length of the string is, and then I'll use the function string length and pass in the variable hello world. Now when we run this, we get the result is hello world as expected, and the string length is 11. Now that we know how string works, let's dive a little deeper into the memory allocation. This file just lets you understand the beginning of how to allocate and deallocate memory for strings. Here is where we're gonna use Malloc on the pointer. It may look like complicated syntax at the start, but eventually you'll get the hang of this with practice. So we want a malloc. So all we are doing is really allocating memory. So we want to allocate 10 elements of memory. So that's n. And since this pointer is an integer, as it says in the beginning, int star, that means 4. So we want to hold 40 bytes. And since n is 10, we want to do n times 4, or n times the size of an integer. So this just allocated 40 bytes to the pointer. So this shows how much space an array takes. That's the point of showing this. You don't need to know all the details right now of what a stack is, what a heap is. That can be an entire video series on its own. And since we just allocated memory, we can ask the user to enter 10 elements. And then we want to get the sum. So we'll just get the sum by going through a for loop and say for I is equal to 0, while I is less than n I plus plus. And then we want to scan for 10 integers because the user just entered 10 numbers. And we want to store that in the array. So that is where the pointer is. And the pointer is at the beginning of the array. And we just add I each time because the first element is the beginning and the next element is one after that, etc. And each pointer is 4 places off since it's an integer, but it understands that already. So we just have to do plus I. Since I is also an integer, it moves the appropriate amount. So we'll just say pointer plus I. So the first one will be at the beginning of the array, then the next integer, etc. Now we want to add this to the sum. So we can do sum plus equals pointer plus I is where it's stored, but that gives us the location where it's stored. So we want the actual value, so we need to dereference it by putting a star in front of it. Now we get the actual value. And now it works. So let's print whatever the sum is. And since we just allocated it by using Malloc, we need to deallocate it. The rule is for every allocation, you need a deallocation. So how do you deallocate memory? When you're finished with it, you need to free the memory. So let's just free this pointer. And this follows the rule for every allocation. There must be a deallocation. And now let's run this. And it's going to ask us to enter 10 integers. So I'm just going to enter 10 numbers. And it tells me that the sum is 314. And this works. Next, we will talk about typecasting and unit conversions in our C programs. Make sure to follow along with this video series by subscribing and hitting the notification bell, or by clicking on the next video so that you can expand your knowledge about C. Thank you so much for watching, and I can't wait to see you next time!